everybody, this is Miss List, and I'm here today with 4.4 notes on chemical and physical changes. So a physical process occurs when a substance undergoes a change in properties, but not a change in composition. And a big focus of this section is how these are represented in particle diagrams. In the picture to the right, we have solid ice crystals or a snowflake, and I can tell that this is a solid water because of the way it's spaced out. Water is one of the only solid particles that is less dense than its liquid. That's why ice will float, but most solids are more dense than their liquid forms. So again, would be considered a physical change because I still have one oxygen, two H's. There's no change in composition as I move from the left to the right. So that's an example of a physical process. Another example of a physical process is when I have a separation of a mixture. So in this example, I have a mixture on the left represented by the two different colors of the circles or the dots. I'm using a filter to separate out the purple ones. Maybe they have a bigger size, and the green ones are smaller, so they pass through the filter into what we call the filtrate. This ties into some of our Unit 3 things that we talked about with separation of particles. The opposite of a physical change is a chemical change or a chemical process. This is where a new substance is formed and it will have a different chemical composition. During a chemical process, bonds are broken and bonds are formed. Examples would be any of our types of reactions that we've talked about in our previous units. And then this is actually a particle diagram of a chemical reaction happening. This is methane, which is CH4, reacting with oxygen gas to form carbon dioxide and water. The number of molecules corresponds to my coefficients. So this is going to be a coefficient of 2 in front of oxygen and a coefficient of 2 in front of water. Here is an example of where something could possibly be both a physical and a chemical change at the same time. Most of the time it's a one or the other type of situation, but many times it's kind of ambiguous. So where that comes into play is something like dissolving. Usually we would classify this as a physical change because I still have the same components. I have sodium and chlorine. And if I evaporate the water, the original sodium chloride would come back. However, we are separating the ions from each other and new ion dipole interactions are being formed. That could make us lean more towards the chemical, but the fact that we can reverse it easily, meaning I can evaporate the water and it comes back, makes it more on the physical side of things. So this is the great debate with dissolving. Here are a few examples. It says a beaker of ice is placed on a hot plate. After 20 minutes, the solution begins to boil. Identify this as a physical change or a chemical change. And I'm going to say that this is a physical change. And then they want us to explain our reasoning. So what is changing during this process? This is a phase change. So nothing is changing from the composition. I'm going from H2O that would be in a liquid phase to H2O in the gas phase, but I'm not changing anything about the composition of my substances. And that's why this is a physical change, not a chemical change. So no change in composition. Our next example says a 4.5 gram strip of magnesium metal is burned with a Bunsen burner. The mass after heating is 5.2 grams. Identify this as a physical change or a chemical change. This is going to be a chemical change. Anything that is burned is definitely going to be chemical change. The other thing that is interesting is when you burn things, you're actually reacting them with oxygen. And so that is the reason why this gets heavier, is because we're adding oxygen. This is actually a synthesis reaction. And so I am creating new substances. So new substance is formed, and that's what would classify this as a chemical process. Here we have our last example. It says solid sodium chloride is dissolved in a beaker of water. The temperature of the water changes from 25 to 48. This process is said to both be physical and chemical. Describe how this has evidence of both. And this is what I was talking about. Be reversed, so easily reversible. The chemical argument would come from the temperature change. A lot of times we have temperature change, an increase in heat or a decrease in energy is going to be signs that something chemical is happening. So the temperature change is what throws this into maybe a chemical possibility. And then we talked about it earlier, there's going to be a dipole interaction, and that's going to be between the bonds in water. Take home points. If it's physical, there's no real change in composition. The original substance is still there. If it's chemical, new bonds are being formed, and it is not easily reversed. Short and sweet for 4.4. Thanks for listening.